This is part 2 of intersection of events and probability trees. I want to start with number 5. A person wishes to purchase a DVD drive for his laptop computer. Assume that 83% of the drives are made outside the U.S. Of the U.S.-made drives, 3% are defective, and of the foreign-made drives, 6% are defective. Determine the probability the drive purchased is U.S.-made and is not defective. So on this problem, you want to set up a probability tree. And there are really two things to worry about. Is the drive made in the U.S. or is it foreign made? And I'm going to represent it like that. And also, is the drive defective or not? So let me represent that event with D and D prime, or D complement. And you're supposed to label every one of these little branches with a number, a probability. And in the problem it says 83% of the drives are made outside of the U.S. That means the probability that it is not made in the U.S. is 0.83. Now it doesn't give us a probability for it being made in the U.S., but you just have to subtract 0.83 from 1 to get 0.17. So you can label the other branch like that. Of the U.S. made drives, 3% are defective. So that means 0.03 there and 0.97 there. Subtract from 1. Of the foreign-made drives, 6% are defective. So 0.06 is the decimal equivalent to 6%. Subtract that from 1 to get 0.94. There's the probability tree. Determine the probability that the drive purchased is U.S.-made and not defective. So you essentially would travel along this branch because it says U.S.-made and at the same time not defective. So you actually multiply those two numbers together. So it's 0.17 times 0.97. So I'll tell you what I get. .1649, and it says 4 decimal places. So kind of a tricky problem because it involved sketching that probability tree before we could even do any calculations. But let's try this next one, number 6. Imagine a subject is taking part in a study to test a new cold medicine. The probability that the drug that the subject is taking is drug A is 20%, that it is drug B is 40%, and that it is drug C is also 40%. From past trials, the probabilities that these drugs will improve their condition are 20% for A, 50% for B, and 70% for C. So that's that they improve the condition. Draw a tree diagram to illustrate this drug trial situation. Okay. And on my computer, they actually give me 4 different choices. It's multiple choice. But we can actually sketch this from scratch. So I would start by deciding which drug we're taking, A, B, or C. But we are going to set up another probability tree. And then after that, decide whether the drug worked or not. So did it improve or not improve? And we just have to label all the branches with these numbers. So the probability that it's drug A is 0.2. For the other two, 0.4. And the improvement probability is 0.2, 0.5, and 0.7. So notice that we do have 3 branches that we have to calculate ourselves. Well, if there's a 20% chance that drug A improves the patient, that means there's an 80% chance that it doesn't. So to get the other number, subtract from 1. And you just have to pick the right selection. So that was number 6. Let's try number 7. Assume that you are drawing 2 balls without replacement from an urn that contains 10 green, 9 blue, and 4 red. So we're selecting 2. And this is without replacement. So we do not replace, which means we throw the first one in the trash. What is the probability that you will draw a green ball and a red ball? And they give us a hint. There are two ways that this can happen. So green and red, this kind of reminds me of some of the other card problems. You have to worry about both orders. So let's assume that the green is first in the first case, and the red is second. And then we'll assume the red is first and the green is second. We'll calculate those probabilities and then add the two numbers together. So how many balls do we have total? It looks like 23 to me. 19 plus 4. So what's the probability the first one is green? It looks like 10 out of 23. And keep in mind this is without replacement. So we're going to throw the first one away. So that means there are only 22 left to choose from on the second draw. And how many of them are red? Well, the first one was green, so it sounds like we still have all 4 of our reds. So that's the first probability. Now let's do the second one. Well, we start off with 23. How many are red? 4. But we're throwing that first one away. But we still have all of the green ones left. And we started out with 10. So notice that both of these probabilities just happen to be the same number. I think that happens most of the time when you switch around the order like that. So just calculate one of them and multiply by 2. And I get 40 out of 253. So last problem, number 8. You want to purchase a DVD drive for your laptop computer. And this one's kind of similar to one we've already done. Assume that 75% of the drives are made outside the U.S. Of the U.S.-made drives, 8% are defective. Of the foreign-made drives, 9% are defective. If your drive is defective, find the probability that it is foreign-made. So this one is really a conditional probability problem, but just like before, we have to set up a probability tree first before we can even use the formula for conditional probability. And on these, I would try to decide whether it's made in the U.S. or not first, and then decide whether it's defective or not second. Try to fill in all the branches with numbers. 75% of the drives are made outside the U.S. That means 25% of them are made in the U.S. Of the U.S.-made drives, 8% are defective, which means that 92% of them are not. Of the foreign-made drives, 9% are defective, which means 91% are not. Now let's do the conditional probability part. If your drive is defective, find the probability that it is foreign-made. So it is given that the drive is defective. And remember, you always put the given after the vertical bar. Given that it is defective, what is the probability that it is not made in the U.S.? That's the same thing as foreign-made. So use the little rule. That's the probability of the intersection divided by the probability of the event that comes after the vertical bar. So let's do the top first. What's the probability of foreign-made and defective? You'd have to go along this branch, foreign-made and defective, and just multiply those two together. 0.75 times 0.09. And what is the probability that it is defective? Well, notice that there are two different ways for it to be defective. So you have to consider this path and also this path and add the two numbers together. So for the first one, it's 0.25 times 0.08. And for the second defective, it looks like 0.75 times 0.09. So let's plug all that into a calculator. So this one was probably the hardest problem in the section. Because you had to set up a probability tree and also use a formula for conditional probability. And this one says 3 decimal places. I get 0.771. So about a 77% chance that it is foreign made if it is defective. Well, that should do it for this section.